KCC105. For week number 2 assignment, we're going to need to create a regression line. Let's check out what that means. Last week, linear growth, we talked about each hour, every hour, my money changes the same amount. We say a constant amount. We know what the graphs look like in both of those scenarios. I want to say it's fairly basic. Everyone did well in the week 1 assignments. We understand that concept. However, in real life, data doesn't change that way. When I asked you for week 2 to flip a coin using some random simulators, here's what my data looks like. Now, first thing we notice that the numbers change differently. Every time I flip, the dots go up, down, sideways, a little back and forth. We could say they zigzag a little bit. Either way, my data is not perfect. It changes at different rates. So those are all real-world problems. How can we kind of fit this into a linear model? Our goal is to take this data and fit it with a straight line. And you'll see that's what I'm looking for. Now, that line is imperfect, but let's face it, that's real world data. Sometimes it's perfect, sometimes it's up, down. We know how that goes. Law of average, that sort of thing. The next goal we have is, by the way, these lines, we're going to call them a regression line, a trend line. Be familiar with both names. Next up is, once I have a line, a trend line, a regression line, something to fit the data, I want to figure out, can I find the rate of change? Because that rate of change has a lot of meaning in real life. So look at, in this scenario, I've got a trend line, and I also have an equation for it. That equation tells me a lot about the data, and we can use that information. How do we do it? How can we go about taking real-world data, creating a trend line, and getting an equation? Well, we can do it with a formula, but that's not the most appealing route to go. We can also use a spreadsheet. Now, spreadsheet, sure, it's a little bit technical, but still, I think it's going to be a lot easier. And I'll walk you through the process. So, for instance, I was talking about the coin flip data. For week number 2 here in this class, I asked you to, hey, take this a number of times, go find a random way to flip coins and get a number of heads. And I got some numbers, and for the rest of you, feel free to put your numbers in there, but I'm going to work with this data. First step to get a regression line. You got to highlight all the data. So I'm highlighting, and I go to Insert and Chart. And by the way, the directions I'm giving here are for Google Sheets. If you're using Microsoft Excel, the process is going to be similar, but there'll be some nuances, and I'll let you work through that. You can obviously contact me if you have some questions. So the first thing I've done, I have now created a chart. It shows me how many times I flip the coin and how many heads I get. And you see the dots. Like before in the slideshow, the dots are somewhat looking like a line, but there's some ups and downs. But there's that equation. How do we go about getting the line and the equation? You're going to go over to Customize. Down here where it says Series, you click this little arrow, and it says Trend Line. Remember I said regression line, or in this case, Trend Line. So I click Trend Line. My computer's taking some time. Linear, yep. And here's the other thing. I want to make a label for this. So I click Label, and I say Use the equation. And right there, it spits out the equation. It says, here's your equation for your trend line. Perfect. This is for Google Sheets. On Microsoft Excel, you'll find a way to add a trend line, and you'll find a way to add an equation. The clicks are a little bit different, but the process is, roughly speaking, the same. Questions, you can let me know. So I've got this. I have real-world data. I have a trend line, and I have an equation. Your week 2 assignment is going to ask you to do all those things, but stay tuned. I'll walk you through another example. But let's head back to the spreadsheet and see, what do we do with this equation? What does this equation mean? Now, first of all, that number at the back, 5.67, that is called an intercept or a starting point. And the number in front of the x, the 0.427, that's called a slope or the rate of change. And that's what I really want to focus on, the rate of change. Rate of change is like when I'm saying every or each. Now, it's not perfect because those dots don't change the same every time, but we can say that on the average, every flip of the coin on average, I get 0.43 heads. Wait a minute, that doesn't make any sense, but if you interpret it a little differently, I think it makes somewhat of sense. Every flip of the coin, the chance for heads is 43%. And you might be like, oh, wait, that's ridiculous. The chance is 50%. Remember, I'm estimating, and I'm estimating based on real-world data, which is not perfect. 50-50 is perfect, but sometimes you get lucky and sometimes you don't, and so the heads and tails work out differently. So that's the idea of a regression line. They're letting us represent non-perfect data, imperfect data. Let's look at another example. And what I want to focus on, and this is important for the homework, is time sequence data. Data that's measured regularly. And look, I'm saying quantitative. I'm looking at numbers. So every day, every week, every year, what am I measuring? Well, numbers. Every day, every week, every year. Let me think of some examples, like population. Here's the population of the city of Chicago every 10 years. That is time sequence data. Now, some of you got your kids at home. I have a 7-year-old, and you line them up on the doorway and you mark how tall they are each year. you're measuring height every year. That's time sequence data. What about money? Well, let's face it, everybody likes to or has to measure the money, see what I've got in the bank and that sort of thing. That's a time sequence data. And we're going to head to the spreadsheet, and I'm going to show you an example of some time sequence data that we can work with. And in particular, where do I get my time sequence data? I'm going to go to Yahoo Finance. It's a website. Easily you can find it on Google. You can click in this address right here. And I'm going to search. Let's search Google stock price. So I go to this search box and right there, Google. Okay. So I hit enter, and it's going to get me to this website. I told you before, my website's slow here. And it's got some stock prices, but I want time sequence data every day, every month. Well, let's see here. Look at this historical data. I think I can find some. It says daily. Let's go monthly. I'm going to click monthly and hit apply. And then it spits out all this information right here. And it says, hey, every month since 2016, it shows me how Google's stock price is done. That's time sequence data. So I'm going to highlight all of that in my web. I'm going to copy. I can right click and hit copy right here. And then I'm going to go to a spreadsheet. I'm using Google Sheets, Microsoft Excel. It's going to be very similar. Click a square. I am going to go Control V, which pastes the data right here. Now in a spreadsheet, I have all the data, the time sequence data about Google. And I want to graph it and find a trend line. All right, here we go. Now, there's all these different measurements. There's opening stock price, high stock price, low. No, let's go for the closing price right here. And there's an adjusted close and a close. Really, there's not much difference. But what I'm going to do is I'm going to look at these adjusted closing prices. So it means I'm going to take these guys and I'm going to delete the ones next to them. And I'll show you why I'm going to delete them. Because this is time sequence. In other words, there's an order to my data. What's the first data I have? Well, way back here in and this one's 0, so I'm going to delete that. That doesn't really help me. But this data is the first one I have, and that's in November. So I'm going to put a 0. In math, 0 is a good starting point. Next up, that's 1, that's 2, and then I'm going to kind of going backwards. You'll see that these dates are in reverse, so I got to put my numbers going upwards like this. Okay, and there's a shortcut. I can actually just highlight a couple, and see that little box in the corner? I click that, and I pull it up, and it creates a pattern for me. Now, I've got time sequence data. Here's the stock prices, and here's the time, starting at 0 in 1 month, 2 months, 3 months, 4 months, and so forth. Now, I'm going to highlight the data I want to graph, like we did before. This is going to sound familiar now. Hit Insert. I'm going to hit Chart. Well, that's giving me a bar chart. For time sequence data, we like to go, click this, and we like to make a scatter plot, or you could do a line chart. But the scatter plot's the best one we're going to work with in this case. So I'm going to hit this scatter plot. You can see the dots. Once again, I sort of see it working like a line, but it's not perfect. A couple months going up here and a couple little wrinkles going downwards. Okay, now there's something about a trend line. So I go to Customize. I go to Series, Trend Line, Linear, Label. No, I want to use an equation. So I click that. And ta-da, it shoots out an equation for me right here. I now have taken time sequence data I found from the web. I graphed it, and I added a trend line and an equation. I'm going to head back to the PowerPoint and just talk about what does that regression line mean, and then you'll be able to think about it in terms of your own time sequence data. You'll pick your own. Don't use my Google example. And that'll be part of your week 2 assignment. Okay, so here's my stock price for Google. Here's my trend line equation. Might be a little differently because I think that the data changed since I made this graph. This is made ahead of time. Let's see, that number right there, 767, that is the intercept, or another way to think of it is the starting point. And what's that mean? It means I started measuring the stock price when the price was about 767. Now I'm using that word about. That's critical because, remember, this is not perfect. This is not an exact science. Regression lines, trend lines are not perfect. Next up, that number, 20.4, that is the slope or the rate of change. What's it mean? It means every month the stock price changes about $20, rate of change. And once again, about. You don't want to say $20.40 because, 40 cents is, I'm trying to be too precise, but this is not an exact science. You say about $20. On average is another way to say that. Approximately. All these different ways because, remember, your answer is not the perfect answer. It's an average answer. It's an approximate answer. And you know what? And there's another way you could phrase every month because we can't say every month forever and ever and ever. We could say every month during the period I studied. Or you could say words like that which qualify, which say it's not a perfect science. We can't say that every month going forward it's going to be $20. It might change differently. So at the very least, we know how to take time sequence data. We know how to create a trend line and to get an equation. Now we can predict with it. So what if I ask, well, what's the price going to be in December 2017? Well, I started measuring in November 2016, so that's my zero. That's my starting point. And then so the next one would be 1 month, 2 months. And we saw this before when I was working on the spreadsheet. So if you count in the future, December 2017 is equal to 13. Now I can predict because I'm going to plug that 13 into the regression equation. 13 goes into that regression equation. And when I say plug it in, it means you're going to multiply it and then add. That's a calculator problem. The calculator spits out that, but I know it's going to look like that because we're dealing with money. And once again, I got to put this back in my problem. I'm talking about stock prices for Google. So I'm going to predict the stock price will be $1,032.20 in December 2017. But think about this. Predict. Well, how did I predict? We got to be careful about when we're saying these things. And we got to be careful about that number. That seems a little too exact. So when you're writing this, why don't we say based on past performance? Because we can't predict perfectly. And according to trends and early data. Thinking of things in those terms help me frame this in the proper way. And the other thing is that number is too exact. So maybe you can say, well, I'll pick 1,000 instead, or $1,030, or $1,025. This is a judgment call. You get to pick what you want. But if you're trying to be precise to the penny, I'm going to call that being too exact. Kind of round it off. So maybe I'll say this instead. I'll say based on previous performance, I'm going to predict the stock price will be about $1,025 in December 2017. So you see what happened here. You have time sequence data, goes to regression line, goes to equation, goes to a prediction like this. That's a lot, but break it down. You can watch this video a couple times through, see the process, and you're going to apply it in your week 2 assignment. Any questions? Please let me know. Email, give me a phone call, however you need, but this is the method we'll be using for week 2 assignment.